Now, how do you decide which merging strategy to use? This is crucial because a wrong choice can make things worse instead of better. I've developed a decision framework based on several key factors. First, consider the stability of your variance. If you have a stable taxonomy that grows predictably, like user roles in a content management system, polymorphism works beautifully. The roles are well defined and don't change often, and you might add new operations or refine existing ones. If you are frequently changing rules like pricing matrices or business policies, data tables are much better. The business can change the rules without requiring code changes, and you can manage the complexity through configuration. If the client already controls the logic, like filtering operations or transformation pipelines, higher order functions are ideal. You're not creating new complexity, you're just organizing existing logic more effectively. If you're dealing with evolving external APIs or complex integration scenarios, adapters are the way to go. You need to isolate your code from external changes and complexity. Next, think about the size of your decision matrix. Small and growing matrices work well with polymorphism because each variant can be understood independently. Large and static matrices are perfect for data tables because the tabular format makes them easy to validate and understand. Simple predicates are ideal for higher order functions where the logic is usually straightforward. Complex integrations need the abstractions that adapters provide. Consider the trade off between readability and indirection. Sometimes a simple if statement is clearer than an elaborate pattern. But when complexity grows beyond a certain threshold, the patterns pay huge dividends in maintainability. Now, here's my rule of thumb. If a new business rule requires adding exactly one line and no new branch, your merge strategy is paying dividends. If you're still modifying multiple places when requirements change, you haven't found the right abstraction yet. Now, let me be clear about something important. Not every conditional should be merged. There are times when a simple if statement is exactly the right choice. Don't over engineer single occurrences. If you have one method with one simple conditional that's unlikely to grow, a three-line if statement might be much clearer than any pattern with five classes. If branches have genuinely different logic with nothing in common, keep them separate. The patterns I have shown you work when there's some underlying similarity in the operations. If the branches are completely unrelated, forcing them into a common abstraction will make things worse. In performance critical code, remember that virtual dispatch and object creation have overhead. If you're in a tight loop processing millions of records, a simple switch statement might be faster than method calls to interfaces. And in simple domains where the business logic is genuinely simple and stable, sometimes straightforward conditionals are the right choice. Don't add complexity to solve problems you don't have. Now, let me leave you with the big ideas from today's lessons because these are the insights that will change how you think about code organization. First, case splits multiply complexity exponentially, not linearly. Each new branch doesn't just add one more thing to think about, it doubles the cognitive load that developers must carry. This isn't a theoretical problem, it directly impacts your ability to understand, modify, and test code. When you see scattered conditionals in a code base, you're looking at exponential complexity hiding behind what looks like simple linear code. Second, merging strategies compress decision surfaces into authoritative places. Instead of having the same logic scattered throughout your code base with subtle variations, you consolidate it where it belongs. This creates what I call single points of truth for business rules. Third, choose your strategy based on stability. Use polymorphism for stable taxonomies, where the types are well defined but operations might grow. Use data tables for changing rules where the structure is stable but the content changes frequently. Use higher order functions where the client already controls the decision logic. Use adapters when external complexity is leaking into your domain. Fourth, linear reasoning wins every time. Fewer execution path means clearer understanding and easier testing. When you can follow a straight line through your code instead of navigating a maze of branches, both you and your colleagues will be dramatically more productive. The mindset shift I want you to make is fundamental. Stop thinking, I need to handle all these different cases in line. Start thinking, how can I move this variation to a single authoritative place? This shift from scattered handling to centralized authority is what separates maintainable code from legacy nightmares. The business impact of this approach is significant and measurable. You get faster feature development because new cases require minimal code changes, often just adding a new implementation rather than modifying the existing code. You get fewer bugs because centralized logic reduces duplication and inconsistency. Maintenance becomes easier because changes happen in one place, not scattered across the code base. And testing improves dramatically because you test strategies and implementations, not permutations and combinations. Now, remember, software is about making the right things easy and the wrong things impossible. These techniques help you to achieve exactly that by organizing complexity rather than fighting it. Thank you for your attention, and I look forward to seeing you apply these concepts to create more maintainable, understandable code in your day to day